What is bagging?
So from the same data set, we create different data sets and try to train the model on those different data sets. Then we aggregate the result.
Very good high level explanation, but let me dig a bit deeper. So how random forest works is, or bagging works is, it takes bootstrap sample and it takes square root of total number of features n every time you have to train the model. Bootstrap sample is 70% of the data set it picks randomly with replacement. And then let's say you have 16 features with you total, it picks only 4 features out of those randomly. And then you build a decision tree using the 70% of this data and these 4 features. So your one decision tree is done. Second, for second decision tree, you do the same thing. You again take random 70% of the bootstrap sample, and then you take random again 4 features, and then you build the model. So like this, you keep on building the model. Right? So you stop at the time wherein you see that your error is minimized and stabilized. With this, you are reducing the overfitting chances which had in the decision tree, because decision tree takes all 16 and goes up till the maximum depth. But here you're trying to get rid of overfitting, and at the same time you're trying to reduce the bias by taking the average or aggregation of the all the results. You're not just relying on one decision tree here. So you're making it strong by combining all the decision tree results and aggregating it. If let's say this decision tree predicts is gonna churn, if this decision tree predicts not gonna churn, he's gonna churn, so on and so forth, then you take a mode of it. Whichever is highest, you say, oh, it's gonna churn. If it's a regression problem, you take an average of it. This is how your bagging works. Correct? You
Yes,
should understand this concept in detail, end to end. If you still have some hiccups or if you don't understand, I would recommend you go back and watch the recordings. Very, very, very important. How it works conceptually. What is bootstrap sample? Why is square root of n? How many trees I need to build and whatnot. Okay. So once you know this bagging, it's easy to understand boosting. So boosting again is a combination of or ensemble of multiple decision trees. However, in this, you don't do this. You build your decision tree as usual. You compute the error by comparing it with actual. And for wherever it's a mistriggered or wherever there are errors, those gets tuned in the decision tree too to take care of those errors. Let's say here the error is 10%. So 10% misclassified. Here on those 10%, decision tree is fine-tuned in such a way that these 10% are taken care. And with this, maybe there might be error in some other, maybe your error might still be 8%, or it might go to 12%. Because while you're trying to fine-tune the model to fix this error, there might be the chance that rest of the ones which were predicted good by this decision tree might end up being throwing error. Correct? Am I making sense?
Yes, sir.
Again, it's sequential. It's sequential. The error of this is fed to the decision tree 2 in order to fine tune so that the error is minimized for those 10%. Similarly, the error for this is fed into decision tree 3 so that those errors are taken care of, and so on and so forth. It's sequential. And then again, finally, you take an average of these. Because you cannot say that, oh, this is best, this is best, this is best. All of these are still a weak learner. All of these have some errors. But if I take an average, those error gets nullified and you kind of get a best fit. So you don't do any feature sampling, you just do data sampling, and then you just keep on building the decision tree. However, bagging can run in parallels. All the decision trees are independent of each other. Here it's not. It's sequential. Decision tree 1 error is fed into decision tree 2. Decision tree 2 error is fed into decision tree, and so on and so forth. So until all the data points are covered, this boosting keeps on running. Clear? And again, you take an average. Or you might take weighted average also, giving some specific weights to initial decision tree and then later decision trees. You understood? And this all this error compute which happens, that works based on, I'm sure you know all of this. What is this? You know gradient descent, right?
Yes, sir.
So I need not to explain. Okay, good. So that's why it's called as gradient boosting machine. It's keep on boosting your accuracy by taking care of errors as we move from decision 1 to decision tree n. So this is how your boosting works. Now, what is the stacking? Have you heard of this?
It is a combination of bagging and boosting.
No, but a good guess, good attempt. So again, yes, you run your boosting as it is or bagging as it is, but on top of it, when you're trying to take an average here or a mode, you don't do that. Rather, you build another model on top of it. So use this output. This output is fed into another model, which will throw you whether it's a churn or not. So having another model on top of these ensemble models to make a decision instead of simple aggregation is your stacking. And another difference of stacking is it can be any algorithm. Here, if you look at it, backing all use only decision trees. It's an ensemble of decision trees. But stacking, you can use logistic regression here, decision tree here, SVM here, and so on and so forth. Stacking, there is no library. You have to build it your own by using multiple algorithms and then assembling it. And then finally building another model on top of the outputs of each of the algorithm to say finally yes or no. That's your stacking. Clear? So maybe I'll show you. Backing, boosting versus stacking. Ensure you get this registered in your mind. Okay. Hope you read all of this and you understand it clearly. Clear with bagging, boosting, and stacking? Or any doubts there?
I have to doubt on stacking, sir.
Yes, please. Yes.
I did not get the concept exactly.
So you still did not understand. Okay, let me. I did not explain it though for you to understand. I just gave a high level introduction, but let me explain now. So let's say you want to build a churn model. You first build logistic regression on some 70% sample. And then you build decision tree on another 70% sample. Again, they can have overlap, that's okay. You build maybe let's say SVM and so on and so forth on another 70%. Maybe you build another logistic regression on 70% of the sample, random, so on and so forth. You keep on building maybe 500, 100 or whatever models. Now, finally, you have output from this model, every model. Let's say one customer example. For one customer, from each of these model, you will have yes or no, 1, 0, 1, 1, 0, correct? And then for this customer, you already know the target feature, whether it's actually churn or not. So you have your actual, which is Y, 1. Now again, these individuals will go as an input to your another model, which is logistic regression. The logistic regression takes these as an input and then predicts Y, 1. Oh, again, it trains this pattern. So whenever you're seeing these many ones and these many zero like this, you predict 1. So finally, rather in random forest or sorry, in bagging or boosting, what you do, you take an average or weighted average of this or a weighted vote of this, correct?
Yeah.
3 has come 3 times, 1 has come 3 times, 0 has come 2 times. So it's 1. So it's churn. That's all you do there. Here, you again build a top model on top of this outcome to finally predict whether you say churn or not.
Got it, sir.
Okay. All right. What next? So XGBoost, AdaBoost, and GBM are just variants of it. You can just explore. There are like minor customization in each of this for you to understand. I'll leave it to you all. Now that you know boosting and stacking, you should be able to easily get that. Okay, so now any questions on mini team project or any open questions on NLP or any questions on text generation or text summarization? For next 20 minutes, we'll touch on these 4 areas and then we'll close.
Actually, sir, one quick question on the mini project.
Yes.
So, can I share the screen, please?
Please.
Sir, we were trying to. There is some. I mean, I feel there is some issue with. We tried clustering, but we were not very sure, how to present and all those things. So this is on the same Flipkart data. Now, the area where we are struggling is. So what should be the features? I mean, so we have taken a product name and discounted price description, if for example, try to cluster based on that. So there are two questions to be precise. One is how do we name the clusters? I mean, so try to name like this, and so how it is coming? It is coming from these descriptions. Uh, for the cluster, first cluster, these are the predominant words. But the challenge is this: these words are getting repeated for other clusters. This is for cluster 0.
Exactly. That's wherein building clustering will be a very difficult job. So your objective is you want each cluster to be with similar components so that if any particular product is clicked from that cluster, you will just show them as your recommendations. That is your whole objective here. But with the kind of data, it becomes very difficult for you to cluster them clearly. That's the reason you still stick to similarity approach rather than clustering approach.
Got it, sir. Okay, so I think with this, second question is more or less redundant, but just to confirm, I mean, we can predict for a new data set, we can predict using this model what we have built for clustering. Is it suggested to?
No, no. I think you have a easier low-hanging fruit somewhere, right? Which is you are using similarity.
Yes.
Similarity will do a lot of wonders. Cosine similarity. That's it. Just stick to it. Whenever it comes to text and similarity, you would rather prefer cosine similarity over any of the clustering techniques.
Okay, sir. So this piece of code can be used. Rest may be kept aside.
Yes.
All
Yes.
right.
Maybe you can use this clustering, and then on top of each clusters, you can do cosine similarity to show the more relevant clusters, relevant items.
Got it, sir. Thank you very much.
Okay. All right. Next.
Sir, I have one question. You mentioned about this knowledge graph based approach, right, for recommendations.
Mhm.
Could you please brief a bit about this knowledge graph, sir?
Oh, I mean, it's gonna be very difficult for me, but let me try. So I'll share my screen. The problem is for you, the knowledge graph is not yet done. It is done in your later modules,
Okay.
right? So that's the reason you cannot understand it right away, but I can explain you. So this is how your knowledge graph looks like. Okay. So all you're trying to do is you're trying to capture the relationship between the nodes and the entities,
Okay.
right? So now, again, so maybe let's say mostly in your recommendation systems, right? Maybe collaborative filtering, if you think about. Okay, maybe I like Harry Potter, you like Harry Potter, then there is some other person liking Harry Potter. So within Harry Potter, your line goes against it,
Okay.
right? So it's a relationship between the relationship between entities is defined using nodes and edges like
Okay.
this. That's about. So it's a better way of capturing the relationship,
Relationship. Okay.
yeah, between the entities using nodes and edges. You can somewhat consider it as a decision tree, but it can be cyclic in nature. Decision tree cannot be cyclic. In decision tree, the arrow always goes downwards. You're getting my point?
Yeah.
But here it can go anywhere in any direction. So this is another, right? So just trying to capture the relationship between the data points using edges and nodes.
Okay.
Okay, so I think this will be in your optimization module, if I'm not wrong. So then you'll be easily able to understand. Don't worry. And probably in that module, you can ask, right? Can we quickly build a graph-based recommendation system as an example?
Okay.
All right. What's next?
Sir, one very trivial thing. So while carrying out the feature extraction for different using different techniques, so somewhere we are using list of lists. Somewhere we are using tokenized words itself. So is there any uniform way, or we need to, based on the way we are using, we need to adhere to that?
I think best way is to don't use list of list and all of it. Tokens is the best way to deal with it.
Okay.
So that, I mean, do you have the code handy to show me? I mean, I'll exactly explain you.
Yeah. Yes, sir. So, uh, so for example, this particular uh, this is what co-occurrence matrix. So here the temp list is in different format, and the if I go further, just give me a moment. Yeah, and if we use this continuous bag of words, then this is again list of list. And it took me some time to figure out that for CBOW we need to have list of list, and for some other ways the format is different. So, or I concluded wrongly. That is more important. I wanted to confirm.
No, your conclusion is 100% correct. So usually what happens is tokens will definitely work for most of it. But when it comes to deep learning or probably the state of art embeddings, the way they have written is different. So if you get into their GitHub code, you will understand, okay, what is the requirement and how I need to post it. But yes, so in some places you'll have to get to the list of list, but in some most of the cases you might end up using tokens, directly tokens.
Okay, sir. I mean, thanks for that confirmation.
Yeah. Okay. Anyone else? Any other questions? So I need 5 minutes to talk about the exam, but otherwise we should be good. Any questions?
For the second assignment, part second of the second assignment, uh, the search engine. So, are we supposed to design that? I mean, there are many components. I saw the topology diagram you have provided. It also mentions about solar, etc.
No, 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 no. You like you just showed your content-based recommendation system, right?
Mm-hmm.
Even that's sufficient for me. I mean, that kind of outcomes, that kind of how you implement.
Okay, sir.
No more questions? Should I talk about the exam pattern?
Yes.
Okay. So your exam will have two parts. Part A, and part B. Okay. Part A will have 4 questions, each carrying 25 marks. Part B will have 1 question carrying 100 marks. So your part B question, which carries 100 marks, will be just a real-time problem thrown at you. And you'll have to figure out solution, approach, build the end-to-end solution and create a presentation and submit it. Part A questions are pinpointed, where you're asked to do something giving the data set and you'll have to just do it. 25 marks each. So you'll have to either attempt part A or part B. Are you clear on the pattern?
So in the part B is like we need to implement end to end, right? The data
Yes.
set is also provided. Okay.
Data set, I think I can provide, yes.
Okay. So within 3 hours, will that be enough to build
Yes.
end to end? Okay.
Yes. And not data sets are not given for all the questions. For some time, for some of the questions, you have to figure out your own data set. Because I'm asking you to build the systems, not the solutions. So if I'm asking you to build the systems, which means that you are giving me the system which is trained, and you can use any data set to train. All I need is the relevant outcomes if I input any data to that system. Any other questions? Yes, any questions? So if you have good, and if we don't have any more questions, I think we are good to sign off for the day. And make sure everybody you submit all your assignments by mid of this week. That's wherein I'm going to evaluate and probably send all of your scores.
Sure, sir.
Okay. All right then. So I'm just a ping away. If you have, while you're going through the book, or if you have any questions on any of the concepts, or if you're not able to implement any of the things, please feel free to ping me. We can have a quick call to sort it out.
Thank you very much, Akshay.
Thank you
Thanks
so
a lot.
Sure, sir.
No worries. Yeah. Thanks everyone. Have a good day and a weekend.
Yeah, thank you so much.
Thank you, sir.
Thank you. Same to Thank you.